This is another A-level video looking at the polarity of different molecules. It does follow on from the electronegativity topic, so you must make sure that you've watched that video beforehand or have at least some prior knowledge about electronegativity. What we're going to do is have a look at all these different molecules here and look at the polarity of the bonds in the molecules, and then we can look at which molecules end up being polarized as a result. So we'll get rid of most of these and we'll just leave this one here, which is going to be hydrogen fluoride. So we've got hydrogen fluoride as our molecule. Now, if you've seen the topic on electronegativity, you'll know that fluorine is more electronegative than hydrogen because it's the most electronegative element, which means the electrons in this covalent bond are drawn more towards the hydrogen than they are towards the fluorine. So what that means is one end of this hydrogen fluoride has a slightly negative charge, so a delta negative charge, and one end, this hydrogen end, has a slightly positive charge here. Now that means that the electrons basically spend more time around the fluorine than they do around the hydrogen because they're more attracted towards the fluorine. It doesn't mean that they're never here, it just means that there's a big difference between the two about where the electrons are. So this end has a slightly more negative end than this end. The electrons are still there, otherwise the covalent bond would have been broken. So that's a nice simple example with hydrogen fluoride. Now this molecule is polarized because it has two opposite poles. It has a delta negative end here with the fluorine and a delta positive end here with the hydrogen. Let's look at a slightly more complicated example. So slightly bigger structure. Let's look at trichloromethane. So we've got trichloromethane here, CHCl3. Now we can see with this one, what we have is we have three chlorines which are more electronegative than the carbon. So we'll have a delta negative chlorine there, another delta negative up here, and we'll have another delta negative there. Now if we draw this structure, we've got the hydrogen at the top, we've got one of the chlorines coming out towards you, which will be delta negative. One of the chlorines are going into the board, which is delta negative as well. And then another chlorine here on the plane of the board, also delta negative. So again, these chlorines are more electronegative than the carbon. So the electrons are drawn more towards the chlorine than they are towards the carbon. So we have again a polarized molecule because we have one end delta positive, then we have this end here as delta negative. If we have a look at another example, we've got water here. Again, we have a polarized molecule because we have delta positive hydrogens, because the electrons are drawn towards the oxygen, where we have a lone pair here, another lone pair here, and we have a delta negative end on this oxygen here. So water is polarized because we have our delta positive hydrogens, and then we have our delta negative oxygen here at the top. We can look at some more examples. So just to make some space, I'll move these ones away. So our next example is tetrachloromethane. So we've got a slightly different situation here, where we've got all four atoms bonded to the carbon. They are all chlorines. They're all more electronegative than the carbon, so they'll all draw electrons towards themselves. If we draw this structure, again, confused with the other one. So we draw this particular structure here. We've got the two chlorines at the one going up, that's this one here. We've got the one coming towards you. We've got the chlorine going away from you here, out the back. And then we've got the other chlorine here on the surface of the board. So just rearrange that so it kind of matches the camera. So we've got our delta negative chlorines again. And this time we have our delta positive carbon here in the center. Now, whilst these bonds are actually polarized, because you have a difference in electronegativity between the two, the molecule itself is not a polar molecule. And that's because the molecule is symmetrical. So in all directions, there is a negative charge. So this is not a polarized molecule. So this is non-polar. So it will have polarized bonds, but is not a polarized molecule. If we go back to our hydrogen fluoride, you can see how this is different, because we have our delta positive hydrogen and our delta negative fluorine, we'll see this is a polarized molecule because there are two opposite poles to the molecule. Some other examples. So if we look at carbon dioxide, another example of something that has polarized bonds. So we have our delta negative oxygens either end and our delta positive carbon in the middle. Now we'll see the molecule is symmetrical. So the oxygens are more electronegative than the carbon, so they draw the electrons more in the covalent bond. But here, we'll see both ends are negatively charged. This is not a polarized molecule because it is symmetrical. So that's just an introduction to have a look at different molecules. So look back through, try and draw the molecules. It's the best thing to do is have a go at drawing the different ones. Try and work out whether they're polarized or not. The next video is going to look at intermolecular forces that occur because of these different polarities. Thank you very much for watching. Don't forget to like and subscribe. Please also share these videos as well. And then I look forward to showing you the next one.